Hi again, I'm John, and I'm joined by Sergey Sidorovich, an optical engineer at Optics for Hire. And we're going to talk about what optical engineers do in another episode of Optical Engineers at Work. If you're interested in this content, please like and subscribe it. It encourages us and helps the algorithm find more people who are interested in this type of content. Today, we're going to be talking about a project that Sergey managed probably 10 years ago or so. And it was a customer who was a medical device company that was interested in learning more about PillCams. PillCams are little cameras that you swallow like a pill and are used to take images of your digestive tract and colon and intestines. It's sort of a replacement for the very invasive colonoscopy, which people get to look for colon cancer. And there's products on the market, one from Olympus, I think there's some others, but our customer was not in the business of making PillCams, but interested to learn more about how they worked. So Sergey, my recollection of this project is that there were a couple different phases. A PillCam is obviously it's a small thing, but there's a lot in there. There's cameras and lenses and electronics and power and illumination. And as I recall, we shipped you a PillCam, and then you took it apart. Is that right? And did some exploration. So maybe you could tell us about what you did in this phase of the project to learn more about how the internals of a PillCam worked.
Yeah, when we got the samples, we disassembled them and explored how they works. We need to understand the resolution, methods of the illumination used. And at this stage, at this point, we tried and we did it. We estimated illumination system. We had task to calculate or measure somehow irradiation at the object plane. This helps to understand what kind of optics and what sensor sensitivity should be used to create new PillCam, how to make it better, faster, and with high optical characteristics.
So as I look at this, I assume this black thing in the middle is the lens, and then there's maybe 3 or maybe 4 little LEDs on either side. Is that right?
Yeah, you're right. This is a small camera and LEDs around it.
And so the object plane is somebody's inside, it's their intestines. How did you determine where the object plane was going to be? Did you have a set distance, or what did you?
Such optics has very small numerical aperture, but this provides a long depth of field. Not all images that this capsule makes, not all of the images are good. Some of them not very good. And the camera has fixed this forward focal length, and it makes images on the fixed distances, but because of deep depth of field, region between highest or longest distance to the camera and lowest distance to the camera is very wide, and this is why most of the images that made on these distances are good for exploring, for analyzing in the lab.
Okay, so let's look at what you found. What is your second slide is this. So what are these 2 slides about that you are?
These are images of the oscilloscope screen, and in case if we need to calculate the radiance at the object plane, we need to know radiant exposure and time of the PillCam illumination impulse. In this case, we are able to understand irradiance in the object plane and define requirements for the illumination system of the PillCam, of the endoscope capsule.
It looks like they turn it on and then turn it off and then turn it on again for longer. Is that what this is telling us?
This is an interesting fact that we found when we're trying to make measurements in different illumination conditions. When we in the dark room, when we have no any illumination sources and only PillCam works or capsule endoscope works, we have this length of the impulse. In case if we turn on the light in office, for example, the impulse length changes, and we found that depending on the brightness in the object plane, the PillCam changes its length of the illumination pulse. This is required to make images not overbrighted or not dark. It tries to make images with the optimal irradiance in the image plane. This is why it changes length of the impulse. It is very complex to change power of the impulse, its intensity, but it is easier to change its length. And the longer impulse, the high amount of the light is collected by the sensor, and the brighter image we have.
They flash the light, they collect some value back at their sensor, and that determines how long they're going to turn it on to take a real image.
Yes, the first, we suppose that the first impulse is to measure conditions around the capsule. We understand that there are no any other light sources inside the human body, but there are different body tissues, and they have different reflection coefficient and refraction coefficient, scattering coefficients, and depends on these coefficients, reflection or reflected light collected by the sensor differs from time to time, from pulse to pulse. And first shot impulse measure these coefficients in simple words, and PillCam calculate length of the impulse it needs to have good bright image, and use this long impulse of the illumination system to get the image.
Okay, clear. Now this is labeled Olympus. So did you look at two different suppliers of PillCams?
Yeah, these are two different suppliers of the PillCams.
And so Olympus just, do they do the on-off too? It looks like they just have a single pulse.
Yes, and we supposed that the Olympus uses another way to measure required illumination pulse power. We supposed there are two ways. The first, we think that it is right, that Olympus uses information from last signal, from the last impulse, to define time for the next impulse. It is possible, perhaps, that it also has some kind of very fast photodiode that can measure irradiance in the image plane fast and adjust length of the impulse while the impulse.
So there might be another photodiode chip on their board that we don't know about that they're using to determine that. Yeah. Okay.
Sure, we don't know.
Okay, so here is your summary where you've looked at the PillCam and Olympus, and it looks like the Olympus has considerably more radiant exposure and longer pulse times. So generally a brighter system, so maybe they collect more light and maybe are able to use a different kind of camera sensor than the PillCam. Maybe is that a good conclusion?
Not necessary. First of all, these are calculations for the direct measurements, where impulse of the PillCam, time of the PillCam impulse is 10 milliseconds. If we remove short impulse and time distance between the short and long distance, we will have only 7.8 milliseconds. In this case, irradiance for the PillCam will be equal 12.4 to 14.7. Yeah, here it is.
So that's pretty close to.
Yeah, and from another side, PillCam and capsule from Olympus can use different lenses, f-numbers. They can use different camera sensors, and combination of all these things can provide the same results in the image, or different results depending on the processing requirements.
Got it. So one question, you use the oscilloscope to measure the pulse duration. What did you use to measure the irradiance? Did you have a photodetector or something?
No, we hired another company that has very precise and very fast equipment for measurement of the very fast pulses. Direct measurement of the short impulses is very difficult because of most part of the such equipment is slow.
Got it. So they used was it a goniometer, or what kind of tool was that they?
Well, I don't remember.
All right. We measured in our lab the pulse time, and then we had a specialty supplier measure radiance.
Radiance Explorer, yeah, and then we calculated irradiance.
All right, and here's your summary. And so this was just a small part of that project, or an important part of the project. In future steps of it, you were looking at other aspects like the camera and the lens. But I think this is a great example of the different variation of work that an optical engineer gets to do, and certainly an interesting one. PillCam is an exciting technology. I'm not sure that it's taken off. I think people still mostly use colonoscopies, but I might be wrong about that. But understanding more about the optics and illumination of how that works is interesting. So I appreciate your reviewing this work, Sergey. Thank you for your time. Again, if you're interested in this kind of content, please like or subscribe. If you have questions, put them down below, and we look forward to presenting to you future episodes of Optical Engineers at Work. Thanks, Sergey.
Thank you, John.
Bye.